Problems on magnetism, problem set number 9. In the first question, you have this 1.5 meter length of a wire carries a current 4.5 ampere, and the Earth's magnetic field is making an angle 38 degrees. So from the diagram, and the Earth's magnetic field is given as 5.5 times 10 to the negative 5 Tesla. So that is the diagram, and you're asked to find the force. Force is IL cross B or ILB sine theta. All the terms are given here. Theta is, remember, theta is the angle between the current and the magnetic field, which is 38 degrees. So you get 2.6 times 10 to the negative 4 newtons. And in the second question, you have a 5 mega electron volt proton entering a magnetic field in a plane perpendicular. Find the radius of its path. So what is given is the kinetic energy, and kinetic energy is 1/2 mass times velocity squared. Now it's in mega electron volts, it has to be converted into joules, and also you can make velocity the subject and find the velocity, but kinetic energy must be in electron volt, in joules. That is what is done there. So the 10 to the 6 is because of the mega being converted into electron volt, and this is the charge of the electron to convert it into joules, divided by the mass of the proton, because it's talking about a proton. And then the centripetal force, mv squared by r, is equal to q v cross b, which is qvb in this case because it's perpendicular. So theta is 90, sine 90 is 1. Rearrange that equation to make radius the subject, and substitute. The velocity was calculated to be 3.1 times 10 to the 7, so that's what goes here. And that gives 1.8 meter. In the third question, you have a doubly charged helium atom. That means it has lost both its electrons. So its charge is double the charge of an electron. The mass is given, it's accelerated by a voltage of 2100 volt. That means it has an energy equal to 2100 electron volt. So its energy is QV, and that is the kinetic energy. So once again, now find the velocity, and then go back to the centripetal force is QVB, like in the last question. That gives you the radius, and on substituting for the velocity, this is what we get. Plug in all the numbers. That's the mass, and that is the voltage, 2100. Now the charge is 2 times 1.6 because, like I said earlier, it has lost 2 electrons, and 1 by the magnetic field. So that gives 3.1 times 10 to the, obviously there's a calculation mistake there, so it's 1.9 times 10 to the negative 2 meter. And to find the period of revolution, time period is 2 pi times r by velocity. Circumference by velocity. And on substituting, you get 3.74 times 10 to the minus 7. In question 4, the force, the maximum force actually is given, and the current is given, and the length is actually the diameter of the pole faces. So it's a very direct question. Remember that maximum force is I times the length times the magnetic field. Cos theta is 90 and sin 90 is 1. So rearranging that, we can easily calculate the strength of the magnetic field. .2635 Tesla. Question 5 is about a velocity selector where you have crossed electric and magnetic fields. That means you have electric and magnetic fields at right angles to each other, tending to deflect the electrons in opposite directions and thereby cancelling each other out. So a particular velocity, electrons of a particular velocity manage to go through because the force acting on these electrons are, due to the electric and magnetic force, are equal and opposite. And for this, V is equal to E by B, and you get the answer. And in the second case, it says the electric field is turned off, in which case there is only the magnetic field, and as before, QVB is mv squared by r, and now we know that the velocity is 2.5 times 10 to the 6. We can find the radius. By plugging in the numbers. So it's 4 times 10 to the negative 3. And in case you're wondering how we get this formula, the electric force QE is exactly equal to the magnetic force QVB. And the Q cancel out, and that's how you get velocity is E by B. Okay, that's where that formula comes from. In the sixth question, now you have this current carrying conductor in two positions. When it's along the positive x-axis, there is a particular magnetic force acting, and when it lies on along the positive y-axis, there is a different force acting, and then you have to find the magnetic field strength. The formula is QV cross B, so you got to take the cross product here in both cases. B is assumed to be BXI plus BYJ plus BZK, which are its components along the X, Y, and Z axis. And the force is I, L cross B, so the current is 8.2. Now this is how you take the cross product, IJK. And it's lying along the positive x-axis, so it's Li. So you have the 2, 0, 0, which comes from the length being 2 meters, and lying perfectly along the x-axis means there is no y, no y and z components. Okay. Now that's how you take the cross product. To get the I, you go from 0 times BZ minus 0 times BY. That's cancelled. So just take a look at how you find the cross product and try to understand this. Now, on comparison of the coefficients, you find that By is 0 and 16.4 Bz is negative 2.5. So both negatives become positive. And you get 0.152 Tesla. The second case, when it lies along the positive y-axis, the length is Lj now, because j is the unit vector along the y-axis. And as before, you have to take the cross product. This time it's you can see that it's j is 2 I and k of 0 because it's along the positive y-axis, and just as before. And also we now know that the z component of the magnetic field is 0.152. So we know that, and that By is 0 too. So once again, when you take the cross product and compare the coefficients, you see that negative 16.4 Bx is equal to negative 5, because those are the coefficients of the k unit vector, and that gives us Bx as 5 by 16.4, which is 0.305 Tesla. Now we know that we know all the three components, so we can put it together, and that is 0.3 I plus 0.15 K. In the seventh question, which is a similar question, but in this case you got to find the components of the force. It's a proton moving through a magnetic field which is given. The electric field is also given, and you have its velocity. Now, since there is both the electric field and the magnetic field, you have to take the vector sum of the two forces. The electric force is QE, and the magnetic force is QV cross B. So when you put them together, you get the total force on the proton, which is, okay, I'll have to write that. So it's QE, that's the electric force, plus QV cross B. You can take out the Q as common and add them up. In this case, I'm replacing Q by E because it's a proton. It has the same charge as the electron. So the first term is the electric field, and then you have V cross B done as before. So these are the components of velocity, because velocity is given as 6I plus 3J minus 5K. And these are the components of the magnetic field. It doesn't have a K component. So that's the charge of the protons, and then the electric field. I'm going to write 10 to the power 3 as common because there's both, and when you take the cross product, this is what we get. It's just a matter of simplifying this. Collect the I terms together, the J's, and that's the only K term, and times 10 to the 3. Now, each term has to be multiplied with 1.6 times 10 to the 3 times 10 to the negative 19, and you get this. So that is the force acting on the proton. Like I said before, you have to refer how to take the cross product of two vectors. It is basically when you find the I, you go 3 times 0 minus 5 times 0.38. When you find the j, you put a negative and you go 6 times 0 minus 5 times 45. And when you find the k, you go 6 times 0.38 minus 3 times 0.45. That's how you take the cross product. I hope that makes sense. Now, in the 8th question, you have a circular coil, 18 centimeters in diameter, containing 12 loops flat on the ground. The Earth's magnetic field is pointing at an angle of 66 degrees below a line that is pointing due north. You're asked to find the torque, and the torque is NIAB sine theta. But remember that theta, very important point, theta is the angle between the normal vector drawn to the coil and the magnetic field. So 12 times, number of turns is 12, I is 7.10, area is pi r squared because it's a circle, and that's B, and sine 24. Why sine 24? Although the angle is given as 66. It's 90 minus 66, sine 24, which gives 4.85 times 10 to the negative 5 meter Newton. And the B part says which edge of the coil rises up. If you look at the situation here, you will see that the north edge of the coil will try or tend to rise up so that the perpendicular drawn to the face of the coil, that is the normal vector, would be parallel to the Earth's magnetic field. Number 9. Here you have a single loop, square loop, placed with its face parallel to the magnetic field. And you find the torque is given. So just like before, the torque is NIAB sine theta. Remember that there's no force acting on the width of the coil because theta is 0. And the maximum force acts on the length because it is at right angles. Therefore, tau max, because sine 90 is 1, would be NIAB. And so the magnetic field is rearranging tau max by NIA. All the terms are given, and you can find the magnetic field. N is 1 because it's a single square loop. Only one turn. And to find the area, you have to take length times width, but it's a square, so it's length square. That's the area, put that there, and calculate. You get the magnetic field as 1.06 Tesla. Thank you.